Okay, so I'm just going to do this table, right? I'll fix the two questions that we did yesterday so that you guys have them, okay? So with this one, I'll start with the one that we showed you. I showed you multiple things. So we'll go 2x squared minus 27x plus 36, okay? So what's nice about this is I'm going to rely on your knowledge of the table and the expansion of the table to fill out the middle. I'm going to rely on that to finish the question off, okay? And I'll fix both these questions, okay? So again, from yesterday, we found that we needed two numbers to multiply to 72 and add to negative 27, right? And then we said, okay, well, we're going to figure out what those two numbers are, right? Turns out that it was negative 24 and negative 3, right? So at which point I showed you, okay, well, let's ignore the decomposition because I think it's more complicated. We just draw the table, right? And we go, okay. We just write the information in that we have. So go 2x squared, and the 36 go down here. And then these top right and bottom left are the decomposition things that we just came up with right here. So it's negative 24x and negative 3x. Okay. Now, ignore all negatives. Just look at numbers and variables, okay? And we'll deal with the sign in a sec, okay? So let's go, okay, what's common between these two? I can take a 2x out, right? And then what's common between the 3 and the 36? I can take the 3 out, right? Okay? And then I'll do the same thing down horizontally this time, right? So I'm going to go this way. Well, you tell me what's common there. I see only an x. I can take only an x out. And then horizontally I can see the 12. I can take the 12 out, right? Because 12 goes into 24 and it goes into 36. So I'll take the 12 out. Okay? Now's where you worry about the signs. So you have the numbers, right? You have the outside, the lengths and widths, and you have to produce the inside. So if I want to produce 2x squared, right? If I want to produce 2x squared, what do I have to multiply? These two guys here. So that one's fine because the sign checks out, right? The next one here, I need negative 3x. Well, how do I get negative 3x? I'm not going to make the negative or the x negative, but I can make the 3 negative, right? Negative 3 multiplied by x gives me the negative 3x, right? Then I'm like, okay, let's go to the next one. 2x multiplied by 12 would give me positive 24x, right? Which wouldn't be useful because I need it to be minus 24x. But if I make the 12 negative, then it makes it negative 24x. Is that okay? Okay.
And the 12 has to be a negative or else the 36 won't be a...
Yeah, exactly. So you do this, worry about the signs after, right? So also, that's good, Aiden. Now we say negative 3 multiplied by negative 12 is positive 36. I suppose right from the beginning that's how you would check, or you would know that the x wouldn't be negative. Because if you got to the end, then you'd be like, okay, I'd get a negative 36 where I should have a positive, right? So always just do the signs after. So you can you read vertically and horizontally like I showed you yesterday, but then just fill in the signs afterward. So what sign do I need in order to make the inside work, the area? Does that make sense? So then your final answer, you just go, okay, I'm going to take the length and width. Oops. I'm going to take the length and width pieces that I have and write them next to each other. Right? So my answer is going to be x minus 12 multiplied by 2x minus 3. And I already know that's going to work because I filled out the inside. Like, I wouldn't have to do the expansion is what I'm saying. Because that's kind of what I already did here when I multiplied the 2, right? To check the inside. Does that make sense? I'll do another one. We'll fix the other ones that we had issues with yesterday. That one we were pretty good with. We just had the wrong signs yesterday, right? The other one we had issues with came from here's the pattern. This is where you have to worry about the signs, right? So if you take this approach every single time you have to worry about anything. If you want to do it kind of the ones that did work out yesterday, if you want to take that approach, and then the ones that didn't work out for a reason, and it's because of this. So we'll go 10. I'm just going to do the 10c squared one now. 10c squared minus 22c plus 4. Okay. Now here's the other thing that didn't work yesterday. The table, I don't know if this is a commonality. I'm not going to say that it is, just in case that I'm wrong. But I found out that if I tried to do the table, if I tried to do the table, I couldn't. I was struggling to get the table to work out if I used these two conditions, right? So you have to do what you have to do, and I think this is just good practice to always do this because we said to do this anyway, is pull out the common factor first, right? Which is the realization that I came to at the end of class yesterday, right? So instead of it looking like this, right? I want you guys to like always be in the practice of pulling out the common factor. Yeah, Noah.
So there's no common factor. We do the man, basically.
You're always going to do man regardless, but what I want you to do, because you'll see here in a sec, I'm going to pull, what can I take out of there? What's the biggest factor? 2.
What common factor is the lowest number that I could possibly be?
Or the biggest number that can go into all of them.
Oh.
So it's when I say GCF, that's the greatest common factor.
Okay.
Right.
40 would be 20, or are you going to put it on 10? 11.
Yeah, so I take out, so the only number that can go in all 3 of those is 2, right? So that's what I would take out. Sorry, 1 sec here. Right? So if I take the 2 out, I'm going to get left with 5c squared, right? Because I divide by 2. And then 11c plus 2. Now, no, I still see that I have to man, right? Because this is, and specifically, it's still a complex trinomial because this isn't 1, right? So I'm still stuck doing this. But the nice thing is now that the man is a lot nicer to find 2 numbers that multiply to 20 and add to negative 11 than it would have been maybe for a bigger number. Like in this case, 40 and negative 22. Right, so the numbers just get scaled back a little bit. They're a little bit easier to like wrap your head around because you've pulled the factor out. Right? So pulling the common factor out just makes the question easier regardless. Sometimes you get lucky when you pull the factor out, that could become 1 and then you just have a simple trinomial there. Sometimes you get lucky with that. Right? So then with this question, I know the 2 numbers that are going to satisfy these 2 conditions. If I were to start with 1 times 10, sorry, did I do this wrong? I did this wrong. Nobody said anything again. It's got to be 10. Right? 5 times 2 is 10. Right? So that's the multiplying, and they need to add to negative 11. I'm going to start at 1, because 1 times 10 would be 10. And then I could make a combination of negatives to give me negative 11, right? So I go 1 and 10. That checks out the multiplying. Then I'm like, okay, well, 1 plus 10 is positive 11. So that's not useful. But if I make them both negative, then it works, right? That also satisfies the addition. Okay. Now I can do my table. Now, I know this is one of the funny questions because B is negative and C is positive. Okay? That's why it wasn't working yesterday. So we saw 2 questions like that, like the last one. B was negative and C was positive. Right? You see the numbers, positive for C and negative for B. This is where we ran into troubles, right? And I never noticed that this was an issue until I put the decomposition beside the table method, right? So just be wary. If you see a negative number here and a positive number here, you got to be careful with the signs when you go do the table, right? Just be careful. But if you take the approach that I showed you here, where you fill in the signs afterward, you don't have anything to worry about, right? So let's, I'll do the table, right? So I'm just going to fill in 5c squared, 2, and I'm going to fill in the other 2 in the top right and bottom left. So I'm going to go negative 10c, negative 1c. And then I'm going to read off the numbers that are in common. So vertically here, right? The things I have in vertically are going to be, in the first one I see I can only take out a c. In the second one I can take out a 2, right? Because 2 goes into 2 and it also goes into 10. And then if I were to look horizontally, right, I can see, okay, I can take a 5c out there, right? And then horizontally in the bottom, I can go, okay, well, I see 1. 1 goes into both. That's it. That's all I can take out of there, right? Then your final step is to go, okay, well, let's put the signs on these things so that the inside checks out, all 4 of them. That's your last question, right? Right? So 5c times c is 5c squared, so that's fine, right? 5c times 2 is 10c, right? That's a problem because I need it to be negative 10c. So I'm going to make the 2 negative, right? Then I go to the next one. Okay, well, 1 times c is going to be just positive c, which doesn't work. I need the 1 to be negative so that it checks out with the negative 1c, right? And then negative 1 times negative 2 is going to be positive 2, right? And then my answer is just going to be this. 5c minus 1 multiplied by c minus 2. Okay, and then I already know that's going to work because I just did the expansion on the top of the table to make sure that it worked, right? That make sense? So the table's really, really good. You just got to kind of like do the signs afterward, right? That's probably the key. And make sure that you pull the common factor out if there's a common factor.